I'm going to turn what I call a tulip bowl. And the whole idea of the demo tonight is to talk about creating smooth, clean curves that are appealing. So this bowl does not have any straight anything on it anywhere. I want a nice smooth negative curve here, positive curve there, and I want the inside of the bowl to follow the outside of the bowl so that it's quite lightweight. This is end grain. This is opposite what we are accustomed to turning when we're turning bowls. The grain orientation of this piece is this way, okay, parallel to the axis of rotation, not perpendicular to it. And that's going to make a big difference in the way I turn this. Okay? When we are turning a bowl, the grain is typically perpendicular to the axis of rotation. So as it turns, the cells are like these straws, and they're turning in this orientation. With this piece, the cells of the wood are parallel to the axis of rotation. So that's going to make a big difference to the way I turn, and you'll see it immediately when I start turning. I'll talk about it as I go, but just so you know, you're going to see some things that are a little different from what you might expect. I should also tell you I'm left-handed. So if you see me do something that looks a little different to you, it could be because I'm left-handed. I turn pretty much ambidextrously, but you might notice some differences in the way I turn. Okay, this is a blank of black walnut. You can see that it's got a hole drilled in it already. That's just to allow me to chuck it easily. What you probably can't see, you might be able to see, is that there's a secondary hole in it. So the big hole is 65 millimeter deep, and the secondary hole is 85 millimeter deep, and that secondary hole tells me when I'm out of wood, okay? I'm going to turn away wood to the bottom of the secondary hole, so that means I'm going to turn it to be 85 millimeter deep, and when I get to 85, I'm going to stop, because I'm going to then shape the outside of the piece so that I've still got a little bit of wood there. I don't want to go through it and make a funnel. Okay? So ask me all the questions you want as I go. I'm going to be wearing a full screen face screen. I always do when I'm turning. So you're going to get a little bit of echo when you talk to me, but I don't mind stopping for questions if you've got them. So, what just hit the floor? Okay, nothing. Yes, sir.
When you say smooth, full curves that are appealing, are you talking about our date for Friday night, or are you talking about the turning?
It's whatever spins your propeller. Okay, so can you see that, Jim? Okay, you've noticed that I've got 38 millimeter marked on the bottom, and I've got a circle drawn on the bottom. That 38 millimeter tells me how much wood I have on this side of the smaller hole, which is, as I said, 85 millimeter deep. So I've got about 38 millimeter of wood to play with here that I'll use for chucking and things, and you'll see that as the turning develops. So the first thing I'm going to do is just get rid of some wood, and you're going to see me do a funny looking cut because I'm going to cut into the side of this grain. Again, the grain orientation is this way, so I'm going to use my gouge to peel into the side of the wood just to waste away the wood quickly. So you're going to look at the way I'm turning this and say, that looks pretty funny, but it's because, again, I'm turning end grain piece, not side grain. And end grain cuts well if you peel it from the side, okay? So here goes. Boy, this lathe doesn't like what I'm doing already. I'm not being that abusive to you. And again, I'm just peeling into the sides of the wood fibers to remove the wood quickly. So the bell is on this end, okay? Now I'm going to just begin to shape it. And I'm going to switch from that gouge to, this is actually a bowl gouge, but it's going to cut nicely on the outside. This is technically a spindle because my grain orientation, as I said, is parallel with the axis of rotation. So technically I'm turning a spindle, but I'm using bowl gouges to do it. And you can see that I'm beginning to shape the horn get my tool rest in a little closer here. Cut away a fair amount of wood already. And at this point, I'm just trying to create a very smooth, clean curve from the horn to the back. This is a piece of black walnut, and this particular piece of wood doesn't want to be cut. It's fighting me a little bit. Sometimes that happens. So I've got a fairly nice curve there, but I'm going to make it nicer. Whoops, sorry, Jim. I've got a triple bevel on this thing now. Obviously, my my grinder rest has moved a little bit in coming up today from my workshop to yours. So I'm going to scrape this, and I know that some people, particularly highly traditional woodturners, think that scraping anything is a dirty word. It means you're a bad woodturner. I have a completely different outlook on things. I think that sanding is the bad thing, and that any woodturner that has to sand too much is not a particularly good woodturner, and anything that I can do to reduce sanding, anything I can do with my tools to reduce sanding, in my opinion, is good woodturning. So I can scrape this and get it really smooth. And I should have commented before I began, I'm not going to finish this piece tonight because I don't want to sand anything in a demo. and I can't finish it if I can't sand it. So I'm not even going to try to finish it, but I will show you how to get to the end. I'll talk you through it, even though I know that I'm not going to produce a finished piece. By the way, how much time do I have? What time do I need to be end? Right now? End now? Okay, I have just short of an hour from right now? Okay. Who would like to be my timekeeper? I'd like for somebody to tell me when I've got 30 minutes left, 15 minutes left, 10 minutes, 5 minutes, 1 minute, done. Okay? You're going to take that on? And I have 55 minutes left. Is that right, Harry? What speed? I don't know. 1406. And this little light is just not cooperating tonight. And I'm going to need that light when I start working on the inside of this. Okay, so again, I'm just going to hit it one last time with my scraper to try to eliminate any irregularities in the surface of the wood. Okay? Now at this point, my fingers are better than my eyes. I just want to feel it, see if I feel any irregularities, and I don't. So the next thing I'm going to do is use a tool that is ground off at the same angle as the angle of my dovetail jaws, and I'm just going to cut a dovetail into the end of this piece, and that's how I'm going to chuck it to hollow the interior. And I don't like the way this lathe is talking to me. I'm not quite sure why it's doing that, but something isn't quite as it should be. It should be dead quiet. When you've got vibration, you got trouble. And I've got a little vibration there. So when I was talking earlier about putting a recess on the bottom of a platter, when I was doing the show and tell, I talked about making sure that your recess is exactly the right size. Well, it's also important on a tenon to be the right size. I want this chuck to close around the tenon that I'm going to create so that when it's tight on the tenon, the jaws are about that far apart. Can you see that, Jim? Okay. Those jaws were turned on a lathe and then cut apart when they were manufactured. And they are, the jaws are in a perfect circle when there's a slight gap between the jaw pieces. Does that make sense to everybody? So what, I would say it's about 2.5 millimeter. And by the way, I'm going to talk metric. I'm not going to talk English, because English is, I mean, the Brits did a lot of good things, but their measurement system is terrible. And the metric system is so much better and so much easier to use that I have forced myself to use nothing but metric. So 3 millimeter is about 1/8 of an inch. This is less than 1/8 of an inch. I would say that's about 2 millimeter on a good day, okay? So I want the jaws to close that much around my tenon. So I'm going to play with it just a little bit until I get it just the way I want it.
Would you like the light down?
I'm actually, yeah, let me see if I can keep this one working. If I can, I'll just stay with it. And if I can't, we'll switch it. Or if you want to set it up, oh, that'd be great. Go ahead and set it up, because this light is flaky. Okay, so I'm going to try this on this tenon again and just see how it looks. And notice I'm doing this before I've taken the workpiece out of the lathe, because once it's out of the lathe, I can't adjust it. So it's still, that tenon is still a little bit big. Oh, that's great. Thank you. Yeah. Oh, much better. Thank you. Okay, I don't want to get it so small I can't grip it. Oh, wow. Okay, why am I so particular about this? It does. It does. Keeps it in perfect concentricity. Yes, sir.
So that you have the whole circle holding it as opposed to 8 points.
Yes. And both of you are right in both what you said, both cases is important. I do not want to crush the wood fibers. If I crush the wood fibers, I'm going to force it out of concentricity, okay? If I can get my chuck to grip it tightly over its entire surface, then it's not going to crush wood fibers, it's going to grip them. But if it's not concentric, it will crush the wood fibers and it will force it out of concentricity. Yes, sir, Chris. That's true, although I'm going to cut this off, so we're not going to see this. But I want this to be very securely chucked, because when I start trying to hollow the inside of this, I'm going to get the walls quite thin. And if I don't have it running true, and if there's any vibration at all, I'm going to have a hard time hollowing it out. So there's a reason why I'm going to so much trouble to get the thing sized properly. Does that make sense to everybody? Okay, so now we're going to pretend that I just sanded this and it's so smooth that it looks more like this one. Okay, just pretend. Oops, wrong key. So I'm going to take it off of this chuck. And by the way, that hole that I drilled in it just made it real easy for me to chuck it. Oh, this is it. Oh, this must be it. Aha. Oh, look. That's a lot better than the old one that these lathes used to have. That's a big improvement. And by the way, the Vicmark lathe that Dave was talking about, I have a Vicmark in my shop that I bought in 2002, and I have never needed to do anything to that lathe. Those are really good machines. So, Dave, if you're having trouble finding somebody to buy it, you should have lots of eager buyers. Okay, so what have I done so far? I've produced this curve, not this one yet. Okay, I'll do that afterward. So what I'm going to do right now is hollow the inside. So I'm going to cut away the center, and I'm going to cut it down to the bottom of that 85 millimeter deep hole that I showed you. And then I'm going to stop on the inside and go back to the outside and make a nice bottom to the piece. Any questions? Okay, this is the challenging part because I want to get this thin, but I don't want to blow it up. Okay, I did bring a second piece of wood in case I blow it up, but I'm going to try to prevail, and I'm going to use a bowl gouge to cut this away. Again, this is a spindle, so you can question why I'm using bowl gouges, but they work better. And I'm more accustomed to using bowl gouges. So even though it's a spindle, the spindle gouge doesn't work as well for creating the curves that we're going to create. By the way, these are particle metal tools. They're CPM 10V tools, and I'm sharpening them with cubic boron nitride wheels. Those can get a tool much sharper than conventional grinding wheels, and the CPM 10V tools are just wonderful from a metal standpoint. So look how smoothly, how clean, how concentric this is running. So I'm going to just start taking some wood away. And you can see now why I wanted that big tenon on the bottom, because I've got a lot of wood I've got to remove, and I want to be able to do it reasonably quickly. And I'm already beginning to watch the backside as I use my gouge. I'm trying to get the walls thin, and I'm looking at where the tip of the cutter is, and then I'm looking at this surface at the same time to try to make sure that I get the walls thin, but I don't want to go through it, obviously. So I'm actually watching both sides of it as I cut. And I will tell you, I'm not going to try to get this real thin. If I go through this, you guys are going to go away talking about how Tom Wirsing went through the side of his demo piece. I'd much rather have it a little thicker than it should be, and nobody will talk about that. Sorry? I'm sorry, I can't hear. Yeah, I don't want to do that. Well, if I made a funnel, it might not be quite so beautiful. And again, I'm trying to watch both the inside and the outside of this as I'm turning. This gouge is sharpened at 40 degrees, so I've got a fairly narrow nose on it, and it's allowing me to get down in there reasonably well. But as I get down in, I'm going to find that I just can't go any further with a gouge, and I'm going to shift to a scraper at some point. I'm also right now going to change to a thicker, bigger gouge because I'm getting deep, and that gouge is not heavy enough to be stiff enough to handle the depth. And obviously I can't get my tool rest very far down into that little bowl, so I'm actually going to switch to a bigger, heavier gouge. And I know that's a little counterintuitive. You might think that the further I get down in there, the more delicate I want the cuts to be, which is true. There we go. Never mind. The question was, do I have a secondary bevel on my gouge? Is that correct? And the answer is yes. If you look at my gouge, the heel of the gouge is ground away, and that just allows me to get around the corner a little better. And in fact, this heel has become too small, and I need actually to knock some metal off of it. So next time I sharpen it, I'll grind a little more off of it at the same time. I can see the bottom of my hole, my pilot hole. Okay, I'm to the bottom of the hole, but I'm having a hard time moving that gouge around in that restricted space. So I'm going to switch to a scraper. And I don't like to remove wood with scrapers generally, but in a case like this, I don't have much choice. So that's what I'm going to do. I'm going to use a negative rake scraper. To get the rest of the way down in there. And this thing is not gonna, this scraper is not gonna like what I'm doing. The wood is not gonna like what I'm doing. And you're gonna hear it start screaming. Can you see anything, Jim? Okay, did you hear it begin to chatter at one point? It did that because I was cutting wood on too broad a surface across the cutting edge of the scraper. So what I need to do is to get it cutting here where I've got more curvature so that I'm not cutting on quite so broad a front and it'll stop chattering. So it chattered there because I was abusing it. Okay, now that little scream that you heard at the end was for a different reason. I'm getting out to the point where it's beginning to oscillate and I need to just use a paper towel or a rag on the back side of it to keep it from oscillating. So I'll do that in a minute, but let's see if I can get it a little bit smoother further down in. And I'm just scraping ever so gently at this point to try to remove any tear out, to smooth up, clean up my curve. Okay, so what I'm doing is using this part of the cutting edge now, which is fairly straight, and I said I couldn't use it down there because it was in too much contact with the wood, but now the wood here is more curved and I can get away with using that. Does that make sense to everybody? I didn't explain that very well. Okay, it's going to chatter on me and I need to stop it from chattering. If I've got oscillations that are making noise, I cannot get a good cut, okay? If you hear your wood talking to you like that and you're trying to get it really smooth, you just need to do something about the oscillations because you can't get it smooth as long as it's oscillating like that.
Hey, Tom,
Yes?
as you're doing this, I've noticed you haven't put your fingers in there, check the thickness. Are you doing that all by eye?
Yeah, pretty much. Pretty much. That's perfect. If you believe that, I got some land I want to talk to you about. Yeah, probably don't want that to hit the floor. Okay, so what I'm going to do is just put a paper towel behind this to dampen the oscillations. And again, I'm using another negative rake scraper. And I'm just trying to clean up this last little bit of wood. And again, I'm not going to sand this at all. I don't want to sand in a demo. So I'm going to use the scrapers to get it as smooth as I can. But a little bit of sandpaper would just make that beautiful. But again, I don't want to sand, so I'm not gonna. And notice that I've got my scraper tucked up under my arm to give it some support so it doesn't flop around. I am just barely touching the wood with it. These negative rake scrapers, if you have to push the scraper into the wood even a little bit, the scraper is dull and it'll do a lot more harm than good. So negative rake scraper should be floated across the wood very, very gently. And I commented that I don't usually like to remove wood with a scraper, but that at the bottom of this bowl I had no choice. That's not the way I typically use a negative rake scraper. I've got a little line of tear out here. Yeah, look at that. Can you see that? I've got a line of tear out there where the wood fibers are rucked up a little bit. It actually is not torn much. It feels pretty smooth, but it doesn't look very nice. And I've also got a little bit of spalting right there, which you know what I'm going to do? I'm going to cut that out because I don't need that much diameter on the rim. And I've got a little bit of punky wood just at the edge of this where I'm into sapwood rather than heartwood, and it's a little punky. So I'm going to scrape this off rather than using a gouge. Yes? Okay. The scraper, this one has a triple bevel on it. It's not supposed to. The back part of it is ground at 20 degrees, and then the cutting edge is ground at 22.5 degrees, which means that the included angle at the nose of the tool is 45 degrees. Okay? These are CPM 10V tools, very tough, abrasive resistant steel. I can get away with a 45 degree angle on the nose of my scraper. I can get away with a narrower cutting edge. That narrower cutting edge will give me a slightly better burr, and that burr will last a little longer. So when I sharpen, the burr is always on the upper side as it comes off the grinder, and it's always on the upper side as I address the tool to the wood, okay? And it's ground again at 22, and the cutting edge is ground at 22.5 degrees. The reason I've ground it at 20 degrees first is just to get rid of some metal so that when I want to put the 22.5 degree edge on it, I'm just sharpening it on a narrow band at the nose of the tool. Does that make sense? Okay. So I'm just going to try to get rid of a little bit of this wood because I do have some punky wood here. And I'm going to round this while I'm at it, just to give it a little bit of a gentle rounding. Let's see if I got rid of that. Yeah. The question was, how thick are my scrapers? And that's another very good question. If a scraper is ground as a negative rake scraper, i.e. it's ground the same on both sides, so that the nose of the tool as it's addressed to the wood is sloping down, you don't need to hold the scraper nose down, because conventional wisdom says you hold a scraper nose down so it doesn't catch. But with a negative rake scraper, it's not going to catch because the nose is already ground down. makes it infinitely easier to control, okay? And if it's kept sharp, it's a beautiful thing for removing just that little bit of wood that you want to remove that you couldn't possibly remove accurately with a gouge. With a scraper, it's so easy to get it right. So, 2 minutes to what? 32 minutes. Okay, I thought you were saying 2 minutes. I was going to say, whoa. Okay. Was there another question? Yes, sir.
So is that essentially, I'm not really familiar with negative rake scrapers that much. Is that essentially a steeper angle skew chisel?
The question is this really just a skew? It actually is sharpened very much like a skew, although if I showed you a picture of my scrapers, you'd see that I have scrapers that are about 10 different shapes, okay? This particular scraper, it works well for what I'm doing tonight, but I have lots of different shapes of the nose of the scraper, and I'm trying to grind the scraper so that it mimics the surface of the wood that I'm trying to cut with it. The difference is that a skew has no burr. You want to sharpen a skew to a very sharp cutting edge, okay? And you don't want any burr. You can't have any burr. A skew won't pick up a cut if it's got a burr. With a negative rake scraper, you want the burr because the burr is the thing that cuts. And if you look at the edge, the cutting edge of a freshly sharpened negative rake scraper, it looks for all the world like sandpaper. If you magnify it about 300 times, it looks like sandpaper under magnification, and it works like sandpaper. It abrades the wood, but it abrades it exactly where you want it and exactly as much as you want it, and it will make the wood so smooth that you don't have to sand much, okay? A lot of people think that scraping is a dirty word. I think sanding is a dirty word, and I love scraping, okay? Does that make sense? Okay, I didn't quite get out all of that punky wood, and I'm just going to cut that down a little more. If this were a conventional scraper, I would have blown this piece up just now. Okay, that looks much better. I've got just a little teeny bit of it there, and I'll leave that there just to remind everybody that we had some bad wood there. Okay, so, and that actually feels pretty good. And it's so thin you can't believe it. Oh, heavens. Okay, so, all this song and dance that I gave you about 85 millimeter deep and all that stuff, what I'm going to do now, since I have cut that hole a little bit deeper than the original 85 millimeter, I'm just going to re-measure it, see where the bottom of my inside is, mark the outside, and if I've done this right, I think I said it was 38 millimeter from the bottom as originally measured. Is that what I said? Okay, so let's see. I just eyeball that. Let's just see where I am. Well, it looks like I'm at about 35 millimeters. So I went about 3 millimeter deeper than the original hole. So what I want to do is maybe part it off about maybe 5 or 6 millimeter lower than the inside. Does that make sense? You guys are looking at me like it doesn't make sense. So it does make sense? Oh, well. I should tell some more stories up here. Okay, so what I'm going to do is begin to part that off at what I hope is the bottom of the hole. And let's just to be safe, I'm going to check it again. Okay, that looks like I'm leaving myself plenty of wood. I don't want to make a funnel. And my my parting tool came apart on the trip up here. And I'm a little nervous about using this tool because I sure don't want it to come apart right now.
Tom, at this point, you would sand the inside.
Yes, that's a good question. As I mentioned, I'm not going to sand anything tonight, but I would have sanded the inside completely right now, and then and I would have sanded the bell down to about here. I'm going to cut this wood away to make a nice curve on the bottom. So I wouldn't have sanded it down here, but I would have sanded everything else. And I'm not going to sand anything tonight, as I said. So you'll just have to pretend that it's sanded. I'm getting some chatter here. I probably have a knot or something in this piece. I'm just going to remove a little bit of wood back here so that it's easier to get my gouge down in there to shape the bottom of the bell. And I want to leave enough wood there that this doesn't want to chatter or break while I'm abusing it, because I am going to abuse it a little bit when I go to turn the bottom of the bell. Okay, so now what I want to do is just begin to remove some of the wood here. And what I'm looking to do is to produce a nice smooth curve so that where I go from a concave surface to a convex surface, I have a nice, smooth, pretty transition, okay? Can you see okay, Jim? Okay, so at this point, I just want to watch what I'm doing until I've got a nice, pretty curve there. I'm getting a little chatter here. I'll have to stop this and see what see why it's chattering that way. Okay, I like that curve pretty well. And what I'm going to do, when I get to the bottom, I'm going to part it off and then put a little dimple in the bottom for my foot. So I just want to get the curve to come down to a fairly small diameter and still look pretty. So again, I'm just removing some wood on the back side of it, so I've got a little more excess. Okay, that's probably about as small as I want to make it. Now I'm going to use a beating and parting tool that has been ground off at an angle, and I'm going to use it as a scraper to get in that narrow space. I'm just using it to try to clean up that curve a little bit. I'm awfully close to the chuck with my fingers, and I really don't want to get my fingers in that chuck. Getting a little oscillation there. That's not my friend. If something is oscillating, you got to stop and stop the oscillation, because if it's making noise at you, it's not cutting smoothly.
About
15 minutes? Okay. So I'm just trying to clean up this curve a little bit. When I ran my fingers across it, I felt some discontinuities. Nothing that sandpaper wouldn't fix, but I'd like to get it a little bit smoother. Sanding may get work smoother, but it will never get it better. You're far better off to get it right with your tool and minimize your sanding. If you're trying to make your turning better with sandpaper, it ain't going to happen. You may think it's going to get better, but it really isn't. So I've got a little bit of a discontinuity there, right down at the bottom. When I take this out of the chuck and turn it around, I'll be able to get at that easily. So I'm not going to fuss with it too much right now. So, next thing I'm going to do is part this off. But if I part it off, I can't sand it, right? So I'm not going to part it off. So I told you I wasn't going to finish it. Okay? I didn't lie. But I sort of misled you, because by the miracle of television, we just happen to have one that has been sanded. I don't know where that came from. Okay? So now we are going to part this one off. So I lied, but it wasn't a real serious lie. Okay. So I'm going to part this off.
Would you normally mark your jaw so you put it back exactly in the same way, same orientation?
The question was, would I normally mark the jaw? For some things I would, but for this, since I'm going to just cut it off and then turn it around and rechuck it anyway, it really doesn't buy me anything to mark the jaws, because I'm not going to put anything back into the jaw. Now, I parted this off not right at the bottom. And the reason is I didn't want to pull the wood fibers out of the bottom of this and create a hole right in the middle. So I've parted it off about 4 or 5 millimeter away from the bottom so that I don't pull the wood fibers out and create a hole right at the bottom. Okay? My spindle lock is right here. You can see me looking for it in the wrong place. So these are cold jaws. And I'm just going to chuck this thing up in the cold jaws. How much time do I have?
12 minutes.
12 minutes. Okay. I got an eternity.
It's going it's going till 8:30. That's what we said earlier. But if you want to go to 20 till.
Oh, I'll be done. I'm almost done. Okay, so I've put this in cold jaws, and all I'm going to do now is produce a little bitty dimple right at the bottom, and that'll be my foot. And I'm just going to use this same scraper that I've been using. I'm just going to sharpen it. Okay, the burr is on the upper side as I address it to the wood. And I want my cutting edge to be right on center. Okay? I should turn that thing down and bring it up. Make the folks in the front row a little nervous here. Whoop. Okay, and I can see I've got a little bit of a discontinuity right there. I'm going to try to clean that up. Okay, this whole piece had been sanded, and I've just made some fresh cuts on it. So it needs to be sanded, this needs to be sanded out again. But you can see that I've been able to put a little dimple in the bottom, and it should sit on that little dimple just fine. Okay? So, questions? Yes?
When you're using the bowl gouge on end grain like that, do you have to do anything in particular to avoid trouble?
You mean when I'm hollowing on the inside? Hollowing on the inside? Well, you're probably aware that when you're cutting into end grain, it is infinitely tougher than side grain. It doesn't like to cut. It wants to dull your tool quickly. To get the gouge to cut, I was putting actually quite a bit more pressure on it in this direction than I would ever put on a gouge when turning a platter or a bowl, for example. So in that sense, yeah, it is a little different. It would be possible to get a small gouge down to the bottom of the inside of one of these, but if you're using a small enough gouge to get to the bottom, the shaft of the gouge is so flexible that it's just all over the place. So it's not going to cut cleanly. That's why I switched to a scraper. And somebody asked me how thick my scrapers are, and I didn't answer the question. I got off talking about negative rake on the grind. But a negative rake scraper does not need to be a big, heavy tool. It can be quite light, and in fact, it's a finesse tool. A negative rake scraper is a finesse tool. I've seen Richard Raffet remove massive amounts of wood with a standard scraper, not negative rake, but with a scraper that's flat on the top and quite sharp. And I've seen him just hog wood out with it. So they will cut really well. A negative rake scraper is really not intended for wood removal. It's really intended for wood smoothing and for just finessing the wood, so that with a negative rake scraper, typically if I'm using it on a bowl or a platter, I'm removing maybe 1% of the wood with the scraper, and the other 99% all comes off with the gouge before I ever begin to scrape. And the scraping is really pre-sanding. It's not to remove wood, it's to clean things up, to finesse them, to get rid of all of the tear out, to make it really smooth, so that when you do sand it, there's almost nothing left to be sanded. So, yes?
Pull that wood out of the center?
No.
That would have eliminated cutting into the end grain.
It's just a matter of preference. If you're comfortable doing a draw cut, go for it. Okay? For me, I use scrapers a lot, so I'm quite comfortable with a scraper. I know that yeah, with the bowl gouge. Would I have done a draw cut? I'm primarily a platter turner. You'd never use a draw cut on a platter. So I'm comfortable cutting the way I cut. I'm not saying it's right. I'm saying it's what I'm comfortable doing. So if you're comfortable doing a draw cut, I mean, I've seen, well, Raffin again, do this funny thing where he gets the gouge sort of upside down and he's I don't know, I don't even know how to describe it, but he can make the gouge cut when I'd have to stand on my head to get it to cut the same way. I don't know how he does it, but he does. So, you know, I'm good with a gouge the way a platter turner is good with a gouge. I'm not good with a gouge the way somebody that does hollow forms, for example, would use a gouge. I never do hollow forms. I just don't enjoy doing them, but I really like a real clean, nicely turned platter with no embellishment, just real clean lines and simple lines. So, yes, sir. Oh, power sand. That's a good question. I never power sand anything. I never power sand anything. That's why I use my scrapers. Because power sanding, if you've got a really, really fine line on something, power sanding is going to destroy it. If you get it really smooth off of the tool, not much sanding is required. And I want when I finish a platter, I want you to be able to run your hand across it in any direction and not feel anything, okay? If I touched it with a power sander, it would destroy that. I can get it much, much smoother with a negative rake scraper and then with not very much sanding. And that's what I prefer to do. Yes, sir.
So Tom, I know when you do your show quality platters, you're very careful about selection of wood and the moisture content and so on. What about this piece? Did you need to worry much about the moisture content? And
Chris, you're reading my mind. You're reading my mind. I'll tell you a funny story. I needed some pieces of wood that are thicker on end grain than what I would ordinarily use in the shop. You know, I'm usually turning side grain. So I go into my woodshed and I find a walnut log. And it's under a big plastic garbage bag that's been turned upside down on it. I can't remember where it came from. It's cold, because I got this out yesterday morning. You know, it was pretty cold. And took it into the shop. I thought it was dead dry. And it was frozen. So I cut up 6 pieces into these shapes to get them ready for the demos and to do a little tune-up in the shop. I left that wood in the shop last night. No, I'm sorry. This was the morning before, the really cold morning. I guess it was Tuesday morning. And so I made 6 blanks, turned a few of them, left the rest of them in the shop, came in Wednesday morning, and every one of them was cracked, really badly cracked. The things that I had turned were fine. They were thin. But the big pieces of wood, I wasted 4 nice big pieces of black walnut. Had to burn them. So the wood is not dead dry. I thought it was. It's not. So were you in my shop yesterday? So, questions? Yes, sir.
Technique-wise, how much of what you just just did with end grain could transfer over to side grain?
I guess I would turn that question around and ask how much of my side grain turning could I get away with doing on end grain, and a fair amount. I mean, you know,
The use of the scrapers. The use of the negative rake scrapers.
well, when I'm doing platters and bowls, I only use the scraper to smooth the wood, to remove just a very slight amount of wood, and I'm not pushing the scraper at all. I'm using it, just floating it across the wood to smooth it. When I was hollowing this thing out with the scraper, I was pushing that scraper back and forth pretty aggressively. So the technique is pretty different. Sharpening the scraper is the same, and keeping it sharp makes it cut better. But yeah, I think the technique is some of the technique is transferable, but some of it you got to do it differently with end grain than you would with side grain. Does that make sense?
Yeah.
Okay. Okay. Questions? Yes, sir.
Do you make your own tools with the CBN steel, or do you buy them?
The question was, do I make my own tools? And I am not an advocate of any wood turner making his own tools, his or her own tools, unless you're a metallurgist. Okay? If you're a metallurgist, I'll forgive you for making your own tools. But if you're not, you're creating something that's dangerous. Because unless you have very sophisticated heat treating equipment and annealing equipment, and unless you're very familiar with the characteristics of the metal, and every particle metal has different characteristics, trying to make your own tools is dangerous, because the tool is undoubtedly going to be either too brittle or too soft. If it's too brittle, it's dangerous. If it's too soft, it doesn't perform well. And unless you're a metallurgist, or unless you have some specific knowledge of heat treating metals and the equipment to do it right, you shouldn't try to make your own tools, okay? I don't feel so strongly about that at all.
So where do you get your tools from?
Okay, most of the tools that I was using tonight are Thompson CPM 10V tools. Both of those are. My parting tool is an M2 tool. That's an old tool. I've had that parting tool for years, and if I were to buy a new one, I would get it out of 10V. But virtually all of my tools are CPM 10V tools now, and most of my tools are made by Thompson. So, yes?
I assume it's okay to grind your profile, so that's not quite making your own tools in the way you described.
Oh, is that what your question was? Oh, I'm sorry. Yes, I am very particular about the shape of every tool that I use, and I freehand grind because I can't get the shapes that I want with jigs, and yeah, I shape everything. So I'll buy the tool with no shape, and grind it to the shape that I want. And I wish I had some more of my scrapers with me tonight, because I've got all kinds of different shapes of scrapers for different purposes. And having the scraper match the curve that you're trying to create is a big help in getting that curve right. For example, the middle of a platter, you don't want any ripples at all. So the scraper that starts in the middle of a platter is virtually flat across the nose. It is very, very slightly crowned. And I'll actually start with that scraper on the right side of center, very gently, and move it to the left, so that I have neither a dimple nor a little mound. I want it dead flat, and I'll continue all the way out to the rim. And as I get closer to the rim, I'll use a scraper that has a tighter radius on the left side so that I can work it up to the rim. So I've got a lot of different scrapers ground in different ways, and yes, I'm very particular about getting the shape the way I want it. So I apologize for my long-winded answer before. Yes, sir.
Hey, a lot of tools that beginners like me end up accumulating are the ones that just say high-speed steel on them. And they're not a fancy mixture of anything, you know, they're really cheap ones. Reshaping those into various types of negative rake scrapers is
Sure, that's how I started. I took my skews because when I opened paint cans with them, it broke the edge off, so I decided to use them for something more useful, and I just turned them into negative rake scrapers. That's how I started doing it. And then as I realized that particle metals were much, much more abrasion resistant, I switched to those. And I have not bought a conventional metal tool probably in, I don't know, 8 or 10 years.
that you consider that high-speed steel as just conventional.
Well, the M2 is a high-speed steel. And all high-speed steel means is that if you get it hot, it doesn't destroy its temper or its hardness.
I was kind of thinking Harbor Freight. I hate to say it, but
Well, there's another thing too. Not all high-speed steel is created equal. Not all particle metals are created equal because the metal might be like CPM 10V. The AISI definition of that is A11. Anybody that makes steel with the right chemical composition can call it A11. Okay, but some of it is junk and some of it is incredibly good. And it depends on the quality of the manufacturing process so that the particles are teeny, because you want the carbides within a particle metal to be about 2 to 3 micron in diameter or in geometry. And if your processes are screwed up, you can produce A11 that's terrible because the carbides could be huge if the process isn't good. Now, it's a particle metal, but if the particles are not small, if the technology is not right, if the hipping process isn't good, if the heat treating and the tempering process isn't good, it's not going to be a good tool.
So how do you know?
Well, you buy it from a reputable maker. You don't buy it from Harbor Freight.
And with 10V and your Cbn Wheels, that scraper lasts for 10 years, right?
My scrapers last a long time. This one's probably, well, this is its second piece of steel with the yellow handle, because I've color-coded my scrapers by color of the handle so that I can find the right one quickly. So this one's probably 7 or 8 years old, but this is its second piece of steel. And I'm very particular about setting the angles on my grinder accurately so that I don't take off any more steel than I absolutely have to when I regrind. And you saw that I grind quickly and lightly, and the tools will last a long time if you treat them well.
What grit do you have on your Cbn wheels?
The question was, what grit are my Cbn wheels? This one I use only for shaping things. It's 80 grit. This one I use for sharpening negative rake scrapers. It produces a burr that's just about the right coarseness. That's a 180. This one is what I use for my gouges that I'm cutting fast with, where I'm just ripping the wood away quickly. And you saw me do that when I first began to turn tonight. That's a 350. And this is a 600, and that's what I use for all of my gouges that I'm using to do finish cuts with. And for gouges used for finish cuts, I'm grinding them at 55 degrees, which is pretty blunt. You know, most people would think you can't cut with a gouge that blunt. But if you sharpen it on a 600 grit wheel, it gets so sharp that it'll cut beautifully, even though it doesn't have a sharp cutting angle. If it's really sharp, it cuts beautifully.
What's the face of that look like? Like a bottom of a bowl gouge? It's like a bottom gouge?
Yes, it looks like a bottom gouge. Yes, sir.
Mine, I use Thompson.
Yeah.
I just got one wheel, I got a 180.
Right.
Thought this hit me, is there a big difference? Because I don't have any trouble really between the 180 and the 350 and the 6 wood.
Well, the question is, how much difference is there between a 180 and a 600?
The whole setup setup.
Yeah, yeah. I'm trying to get my wood really smooth with my gouge before I scrape it, and then I'm trying to get it even smoother yet with the scraper before I sand it. So I'm really focused on trying to get my cuts absolutely clean as a whistle, and that's why I've gone to a 600 grit. I don't turn salad bowls. I shouldn't say it that way. What I was getting at is I always like to put a gallery finish on everything that I turn. And so using a 600 grit wheel on a gouge to turn a salad bowl that you're going to oil and use doesn't make any sense. But if you're trying to turn something that you want to sand to 500 grit or 1,000 grit and really get it smooth and then put a nice gallery finish on it, you need to get it smooth or every flaw in it will stick out like a sore thumb. So I'm focused on trying to get it really smooth. And that's why I'm using a 600 grit wheel for my finishing cuts.
Are those slow-speed grinders?
Yeah, but the question was, are these slow-speed grinders? Yes. Those are Delta. Those are old grinders. You can't get them anymore. And Delta is essentially out of business. Rikon makes a one-horse, low-speed grinder now, which is supposed to be a pretty darn good grinder. I think Jet is producing a 3/4 horsepower low-speed grinder, which I also understand is a pretty good grinder. So, yeah, low speed. And the Cbn wheels are not necessarily heavier than a cast wheel, a vitrified wheel, but the weight is all out at the periphery. So it needs more power to spin it up quickly. So you want to, if you're going to use Cbn wheels, you really want to get a 3/4 horse motor at least on your grinder. And you do not want to mix Cbn wheels with vitrified wheels on the same grinder, because the vitrified wheels can never be balanced. Every time you true them, they're out of balance again. Even if you put a balancer on them, they're going to be out of balance as soon as you true them. With a Cbn wheel, they come balanced and they don't require truing. So you shouldn't mix them, because the lack of vibration is one of the things that makes a Cbn wheel a very effective wheel for sharpening.
Can I comment on that?
Yes.
CBN wheels, depends on what you get. Some are, like Tom's, have a center web with the rim around them that is machined out of one solid piece. Some are a thick piece of steel with the CBN on them. One of the guys that works here was looking at getting CBN. We sell CBN wheels here. Do not buy them if you have a half-horse motor. I have CBN wheels that are from Woodworkers Wonders that are similar to what Tom.
Yeah, two of those are Woodworkers.
2 pounds, 15 ounces. We pulled one of ours out of the package. It's a solid steel one. Mine are 1.5 inches wide too. Ours are 1 inch wide here at the store. 6 pounds, 5 ounces. More than twice as heavy. I would not put our wheels on a 1/2 inch grinder.
Yeah. Yeah, half horse, yeah. So I'm way over time. I am happy to stay and answer questions for as long as you guys want to ask me, but I don't want to keep you longer than you want to stay. Thank you.